Good morning, everyone. My name is Phil Cates. I'm glad this morning that we are having our virtual breakfast at 7 a.m. and we're pleased to have a group, an online group from across the world today. Michigan State University Extension has an online international short course in agriculture extension, and we have participants, I think, from 9 different countries that are joining us this morning to see how we're doing virtual breakfast. So with that, I'm going to say welcome. We're pleased you're here, and we hope you enjoy this 15, I'm sorry, not 15, but actually it's 30 minutes of educational material and then another half hour of question and answer. And so I'm going to turn it over now to our host for the day, Jim Islip, my friend and colleague in the Upper Peninsula of Michigan.
Thank you, Phil. Good morning, everyone. I'm Jim Islip, field crop extension educator in Michigan's Upper Peninsula. And I want to welcome everyone to this morning's virtual breakfast. Our topic today is irrigation and plant disease, and we're featuring Dr. Martin Chilvers, our MSU field crop plant pathologist, and Lyndon Kelley, MSU Extension irrigation educator. We're going to ask everyone, if you have questions, to please type them into the chat, and we'll get to them during the course of this meeting. Unanswered questions, ones that we're not able to get to, we'll address after the presentations are completed. There is one RUP credit for those of you that are certified pesticide applicators for today, for those people who are participating live. Phil Cates will be giving some details about that toward the end of the meeting. We're going to start off with Dr. Martin Chilvers and Lyndon Kelley on irrigation and plant disease. Then we'll move to Dr. Jeff Andreessen, MSU ag meteorologist, with his update on the weather for the week and for the coming week or weeks, and at that time Jeff will introduce next week's speaker and topics also. So with that, I'm going to pass it off to you, Marty.
Okay, thanks, Jim. Good morning, everybody. So this morning we'll talk about irrigation and how that also is a driver for plant disease. So one of I guess there's a couple of major diseases, right? One of those in soybeans is white mold, and then we also do deal with a lot of foliar diseases in most of the crops that we grow as well. But white mold is a little bit different because it starts from the ground. It's not sort of a true or just a foliar disease, right? It's got a very strong sort of soil-borne component that's very important for disease development. And what we're looking at here, of course, is the white mold fungus, the Sclerotinia sclerotiorum, and the resting structure that fungus produces. So these sclerotia, these resting bodies that are produced, survive in the soil for many years, and they germinate with the right conditions to produce these white mold mushrooms, or apothecia is the correct term. And so this is really a key component of our white mold disease in our soybeans and dry beans. And so certainly irrigation is a driver of this. We need moisture for those sclerotia to germinate and to produce those apothecia. But another component of that is canopy closure as well. So those white mold mushrooms that are produced, they really need a certain light quantity and quality. So they need filtered light through the canopy for production. They won't form in complete darkness, and they won't typically form on the bare soil surface. So there's something very particular in terms of cues from light that this fungus is looking for the correct formation of that mushroom. And so of course when we irrigate, we are creating a denser canopy, promoting that. If we do promote that early with vegetative vegetative irrigation events, we're more likely to sort of create conditions that are favorable for that production of those mushrooms and then subsequent infection as well. Moisture also being important for once those spores get released to actually germinate on the flower petals where they actually create disease. And just to sort of demonstrate the impact of canopy closure, here we're looking in the top graph of 14-inch row spacing for soybeans versus 30-inch on the bottom. And I just wanted to point out that red line there as to when we were finding these white mold mushrooms on the soil surface. So in the 15-inch or 14-inch where we get closure a little bit earlier and have some canopy, we see those mushrooms appearing about a week earlier or so than under the 30-inch row spacing where things are a lot more open. And the other really significant thing here is the number of apothecia or mushrooms. So we're seeing about 50-fold more of those white mold mushrooms where we're under sort of narrow rows or 14, 15-inch row spacing as opposed to 30-inch row spacing. So again, that canopy really helps to drive disease. So that's another sort of very important component here. And it creates that microclimate too, right? So we do hold moisture on the soil surface, of course, as we get that canopy to develop, which again is favorable for the germination of those mushrooms and then also subsequent infection as spores move or get discharged from those mushrooms and land on flower blossoms where they primarily infect. We do have just a quick note here too, we do have this Sporecaster app for predicting when those white mold mushrooms are being produced. And it's got a 15 and 30-inch option, and it's also got an irrigated versus not irrigated option as well. So there's really sort of four different versions that you could really run of this model. Again, moisture drives canopy closure. Irrigation during flowering will certainly favor white mold because this is our primary infection period, right? And again, those flowers are susceptible to infection, and that's the primary window when we're trying to look at modifying things in terms of reducing risk or making fungicide applications. It really needs to be applied from beginning of flowering through to essentially the wind down of that primary flowering period. And within that Sporecaster model as well, there's also a row threshold component that you need to check off in 30-inch rows. So again, 30-inch rows where we've got a lot of space between the rows and a lot of air movement, things can dry out. We don't tend to see that risk, and we don't have that favorable sort of canopy for those white mold mushrooms to be produced. And so we've got a question in that app when we're looking at 30-inch rows. Are we at under threshold? And if we're under threshold, the model probably won't run. If we are over threshold, we're getting most of that canopy starting to close, we're getting close to closure, then the model will continue to run and try and predict the risk in that particular field. And just something that a comment that Mike Staten made too, actually, if we're not irrigating up until flowering, you probably want to be running the non-irrigated model, right? Wait until you're actually irrigating to then flip over to the other model. And I think actually it's pretty important to try and run a few different versions of the model to see what is happening. Personally, I find that pretty helpful. Even in an irrigated sense, like what has been the risk that the different models are giving us. Okay, now I'm going to switch over to TaskSpot just because we don't have a whole lot of time. This discussion regarding TaskSpot, is sort of a good model, I guess, for foliar diseases. So we can think about northern leaf blight, grey leaf spot in corn, potentially other foliar diseases in soybean too. For southern Indiana, Illinois, we can think about frog-eye leaf spot, other sort of foliar diseases that are an issue. So pretty much all of our plant diseases require a period of free water on the plant for their spores to germinate and for plant infection to occur. And this is very true with the tar spot disease as well, the Phylochoromatus fungus that causes that disease. We see cycles of disease every 2 to 3 weeks if conditions are favorable. So if we have about 7 hours of leaf wetness a night, that's a factor that seems to be very favorable. And just emphasizing that again, this map on the left there is just a predicted range of tar spot based on environmental risk factors. So the folks that did this study looked at the risk factors in Latin America and applied that to North America or to the US here to see what conditions might be favorable for disease. And to date, they've been very accurate in predicting where tar spot is going to be a primary issue. So looking at pretty cool temperatures, 63 to 72 Fahrenheit, relative humidities greater than 75%, this is monthly based. And then average 7 hours of night leaf wetness, absolutely key. And I think that's one of the really important things we can think about when we're irrigating and how we can try to manage that. And Lyndon will address that a little bit further. I got a couple of quick examples of just how we can drive disease. So Bruce McCullough put this one together. Got a pivot here, of course, and our dry corners. This is just a hybrid planting map. So we've got different varieties of corn out here. And you'll see that in the next aerial imagery, where you'll see a sort of green streak due to that variety either being a later maturing variety or perhaps a variety with greater resistance. So this field had an incredible amount of tar spot in it that developed in 2018. And we had a lot of moisture in 2018 during the growing season in July and August. And so that really helped to drive not only tar spot but other diseases to really amplify on the foliage and cause premature dry down in some situations. And to me, this is really striking, and it's not the only example from 2018. Talking to a lot of other farmers, they experienced this too. Under their irrigation, they actually lost yield, which is very counterintuitive and a little bit scary, right? So if we compare this same area that had the same height, or the area that had the same hybrid in it, where this producer put irrigation on, he's down to about 170, 180 bushels, as opposed to the dry corner where he wasn't able to irrigate, right? So he's about 40, 50 bushels better off, where he actually wasn't able to run the pivot. And to me, that's just incredible. And it actually speaks to the explosive nature of tar spot as well. So it's a little bit unlike some of the other foliar diseases of corn. It just has that potential to really explode. More like southern rust of corn, which we don't deal with too much here in Michigan, but it's just very capable of exploding. Bruce also pulled together irrigation and precipitation events for that location. You can see here in blue all of those precipitation events that were happening. So a lot of rainfall throughout the season. And as far as we know, that producer only ran the pivot a couple of times, right? And that's all it took to really blow disease up and lose quite substantial yield. Here's a photo from Dan Heasley down in Southwest Michigan. This is from 2019. And looking at this field, you would think, wow, you know, this was tar spot again. You would think that putting that irrigation on had really driven disease and created in some major issues, right? Well, perhaps it did drive disease. I don't really doubt that. But 2019 was much drier than 2018. So even though we may have driven disease with irrigation, we needed to irrigate for crop production. So it's a very light soil. So under the pivot, we're around about 225, 230 bushels to the acre. And in these dry corners, we're losing about 30, maybe 40 bushels. So even though we drove disease last year, it was important. And just finally, just a couple of quick things. So Lyndon's going to provide some examples on this, but we've had some anecdotal reports of where producers were irrigating very small amounts, but frequently, so half an inch twice a week, that really appeared to absolutely drive up tar spot, as opposed to neighboring fields that were under more of a 1 inch per week type schedule. So again, that canopy moisture is critical for disease development, and the more you exacerbate that, the worse things can get. So with that, I'll switch it over to Lyndon Kelley for some comments and discussion on irrigation.
Thanks, Marty. So when we irrigate, we gotta almost always have to get the crop wet. There's a few subsurface units in the state, but it's really less than 1% of our total irrigation. So almost all of us are using overhead irrigation. This first slide Marty put in so that you can get a hold of me later. The second slide that he's going to show you is some work done by Dr. Young-Suk Dong, our new irrigation specialist out of Michigan State University Biosystems Ag Engineering. And the red numbers at the top, so the lower graph is the lower sensor, a leaf wetness sensor in the crop. The upper ones, 2/3 of the way up of the height of the crop. And if you look at the red numbers, those are the times that this crop was exposed to more than 7 hours. Marty's, Dr. Chilvers' miracle time frame that could advance the disease. So we're counting the number of times that we got things wet. We need to irrigate to keep yields on these lighter soils, but we want to keep the number of times that we get the crop wet to a minimum. And maybe in some situations, we want to water at a time that it won't produce a 7-hour wetting period. If you look at the first two irrigation applications on that top chart, they were only wet for less than 2 hours. So those applications were made during a time of the day that the crop got wet, the water was applied, but it dried off. So we didn't actually create a time period. You notice the blue bars, each bar represents an hour roughly, or a time increment, I'm sorry. So if you look at those blue bars, there were rainy periods that got us over that 7 hours, and most of them were associated with rain periods. But if you look at the third time period, that irrigation was done at a time period where we got the crop wet, and then it stayed wet for 8.2 hours. So what we want to think about is, can we irrigate in a fashion to minimize the number of wetting events? And we have the same work in soybeans and corn going on right now. Marty, if you go ahead one. So first, do we actually need to irrigate? And that's the whole concept of irrigation scheduling. Dr. Andreessen has been including these charts from the National Weather Service on FRET, which stands for Forecasted Reference ET. It would say that a crop of 6-inch grass is using about 1.3, 1.5 inches of water. So I need a little over an inch of water a week from the root system of the plant to keep that plant growing. We would then have to add about 15% to that number because corn uses more than grass. And then we've got to add another 10% because we evaporate some of the water that we apply overhead on the soil surface and in the leaves. So we're going to need to keep irrigating if we're not getting that rainfall. We just need to do it in a fashion that minimizes the wetting periods. So if we take a look at different means of doing that, very, very few producers have the capacity to only irrigate during the 9-10 hours or maybe 12 hours depending on the day, during the day when we wouldn't carry the moisture into the evening. If you had a situation where you knew that specifically you're bad in the disease and you have issues, you may be able to only run the irrigation from say 8 in the morning till 6 in the afternoon and keep moving forward. But most producers are geared up to irrigate 24 hours a day. So the one thing we have left is how many times I need to irrigate to get that amount of water. If we think about August in either a corn or soybean crop needing about 6.3 inches of water, and that's just the math that we did earlier over 4 weeks, and we're hopefully going to get some of that from rainfall. So I subtracted off the average rainfall. And what we see is that we could do that in 3 1-inch application or 12 1/4-inch applications. And I'll see producers, people will call me with both extremes that are using very large applications or very frequent small applications. But I think there's 2 main themes that come out here. When we're using large applications, we're going to have larger wetting, larger numbers of amounts of water getting to the crop. That's because every time we do an application, we lose about 1/10 of an inch of water to surface evaporation and evaporation of the water off the leaves. So by going to lower applications, we get more water to the root of the crop where it's useful, and we get fewer times that the crop's getting wet. And I think that tends to account for some of the problems that we have. If we have one producer putting his 3 inches of applications on in August in 12 applications versus another one that did it in just 3, we have a 3-fold difference in the number of times we got the crop wet. Artie, I think that ties it up. Oh yeah, there's a few of us that are thinking about putting fungicide on through pivots, this concept of temidation. It's been a hot question the last couple of weeks. There's some information at the websites at MSU Extension talking about this process. By early next week, there'll be a new video up that will help you walk through. But for a lot of producers, the issue is going to be being able to uniformly apply the water with the fungicide in it at a volume small enough that will stay in the foliage at an active ingredient level that will actually control the disease. Most of the labels would say that they would prefer to have about 1/10 of an inch, and that they don't want to be over 1/4 of an inch of water. And so producers with a center pivot, those would be the main targeted producers, they need to look and make sure that their machine is actually capable of going that fast, applying the water in that small of an amount. There's some safety equipment that's required by the label and the state laws. Both in Michigan and Indiana, we require check valves. And then if you're drawing water from a public water supply, we're requiring a reduced pressure zone valve. Positive displacement pumps, the dealers are telling me there's a big run on those, that people are gearing up to do this and that they're seeing positive displacement pump. That's the pump you need to make sure that you're putting on an even application. And then we need the system interlocked, so if any one component of the system shuts down, all of the components of the system shut down. And that's what we use to make sure we don't, that we're actually getting a good uniform application and not putting pure chemical into the system or some other disaster. If you need more information about chemigation, we're going to put it up there on the website. There's already some information there and more to come. Marty, back to you.
Well, I think that's what we have for now. So we're ready to hand it over to Jeff, and we'll take any questions if you wanted to do that, Jim.
We do have one question in the chat box. Where can we get the Sporecaster modeling app?
Yeah, so it's available, and I was just checking actually if it worked internationally, and it looks like it does, surprisingly. So, I mean, that just really depends on where they're drawing the weather data from. But yeah, it's available for free. Just go to your Apple store on your phone, your Apple application store, or your Google Play store on your Android device, and it's freely available. Just search Sporecaster, and that'll get you that app.
Okay, thank you, Marty.
Yeah.
We don't have any questions to address from the chat. Any new ones? So at this point, I'm going to just open things up if there's any issues.
I think a question just came in.
Oh, okay.
On white mold fungicide timing. So the question is, can I speak to efficacy of white mold fungicides or treatments this late in the season, now that we're at the R4 growth stage? You know, I guess the model might still be showing conditions are favorable for apothecia via Sporecaster. And I think that's, you know, with the irrigated model, we're pretty much always at risk, I think, especially in 15-inch row spacing. But fungicides really need to be applied between R1 and R3, right? You know, the primary thing we're trying to do with the fungicide there is protect the flowers. So once we get into that R4 growth stage, there may be some benefit, but it's going to be pretty minimal. Especially once we get into a little bit later here in August and we start seeing white mold actually developing in the canopy. You know, sometimes I get the question, like, I'm seeing a lot of white mold, what should I do? Well, it's pretty much too late, right? Any very late applications there, the damage is already done. So unfortunately, it's you know, the primary times are between R1 and R3. You're most likely to get a return on investment. I think really, you know, now we're just getting a little bit too late to have the best chance of return on that investment.
There's another question in the chat. We're seeing an upturn in tar spot and a corresponding upturn in fields that are being treated down in the southwest part of the state. At what growth stage should we consider late enough that tar spot would likely not cause significant damage?
Yeah, that's a good question. So here's a map of Michigan, or the US here, Midwest, and where we've historically seen tar spot in grey there, and where we've had reports come in yellow this season. We just got one for Gladwin County, came in yesterday. There certainly is a little bit more tar spot. I really haven't seen that many fields where there's very significant pressure. Those that are perhaps at the greatest risk are under irrigation. And they'd certainly be the ones I'd be watching the most. Surprisingly, you know, last year there was an application made, Jason Roth from Winfield made an application at the very beginning of R5. And I want to stress it was the beginning of R5, right? Not halfway through R5 or anything like that. It was at the very beginning of R5. And that actually protected about 20 bushels in that particular instance. Earlier on, they'd actually made an application of fungicide, I believe, at R1. And at that time, they hadn't seen any tar spot. They get to that mid-August time last year, I think it was, and they happened to be at that R5 stage, and they'd seen white mold, sorry, not white mold, tar spot start to come in and be fairly prevalent in that field. And it was an irrigated field, and disease continued to pick up. So where they'd sprayed some strips, they were able to protect. So I think that's pretty much the rare instance that maybe that R5 application timing will be helpful. I think typically, I mean, it's really about managing disease, right? So when is disease coming in? So that's really what it comes down to. Surprisingly, even as late as R5 appeared to do some, have some benefit.
Thanks, Marty.
Yeah, another question there about vegetative applications from Jeff Stock. So regarding vegetative applications for tar spot management, so far we really just haven't seen tar spot develop early enough in the season that a vegetative fungicide application really have any efficacy, say back in June or perhaps very, very early July. We did some studies last year, and it was really those R1 timings, the silking timings, and a little bit later that had the best efficacy. And at the moment, what we're really focused on as well is, I think the question shifted a little bit. Is it silking, or is it the R3 growth stage? What is going to be the optimal sort of timing for tar spot management? And again, addressing disease. If there really is significant disease out there at that early vegetative timings, we're going to be in an awful lot of trouble, because fungicides are great, but they'll only suppress disease and keep that material that's been sprayed protected for about 2 weeks, maybe 3 weeks, and then we'll start to get disease start to develop again. So so we really focus more now, the questions, R1 versus R3 or perhaps later fungicide timings.
Jim, I've got a question for Chris DeFonso. I was
Yes.
I was very surprised to see kind of an explosion of spider mites in soybeans yesterday, and I spoke to a producer, and last week they had some bronzing, but yesterday it was very pronounced, and the spider mites look like they're turning brown. They weren't really a greenish color. So with the rain that we've had and the warm weather coming, how long can we expect that these spider mites are going to be a problem, Chris?
So are you saying that they were turning brown and dying?
Maybe.
So,
I don't know that they were dying.
That's sort of that's kind of my assumption, if that's what you were seeing. So when it was raining, the first thing I thought of was, oh good, we have 24 to 48 hours of kind of that humid kind of conditions under the canopy, and you can very rapidly then diminish spider mite with the entomopathogenic fungi that are out there. Around campus, I haven't seen any spider mites to follow. I don't know if Marty has seen a little area to follow in his plots either, but we just don't really, I really didn't have a place to kind of follow these, but I would assume that in places where there was rain, kind of that steady rain on Saturday and then into Sunday, and it was still juicy into Monday, that there was a lot of killing going on. And that happens very rapidly. Like within days, you would see that those those mites were actually infected. And with a hand lens, you should be able to kind of see that. You will see on the surface of the leaf, there might be something that looks like a mite there, but it's a little fluffy because it has been infected.
I didn't see any spider mites on the tops of the leaves. They were all on the bottom of the leaf.
That's kind of typically, where like a moderate population will be on the bottom of the leaf. They kind of have their mite superhighways there. On corn, it's almost always along that midrib and the bottom of the leaf unless populations get super high. But that would be typical to be kind of on the bottom of the leaf, which is a little bit more protected. But I'm heading up to the Saginaw Valley farm today, and so if there's any mighty edges of fields up there, I'll kind of check them out and see. I mean, another way to do it, if you're a nerd like me, you get a plastic bag and you can pick, you know, your aphids or your leaf hoppers or your mites, and you just stick the leaf in the bag, you know, overnight with high humidity, and you can very quickly see whether there's any pathogens there, because they almost immediately burst out of the little creature and kill them.
All
So
right,
Chris,
great.
will these heavy dews in the morning that on these leaves advance that pathogen?
The dew, if it's dewy for like a couple hours and then by 10 o'clock it's gone, that's not what does it. It would be more of a 24-hour kind of humidity under the canopy, which I think we definitely had when it rained. It rained for quite a while, and it's taken a while to dry up. It's not the top we're looking at. We're looking towards the, you know, the bottom third of that canopy, and not just for spider mite, but other sucking pests like aphids in particular, and potato leafhopper. The other thing, again, the rain just replaces water that plants have been stressed with too, so that just kind of helps out as well.
Martin, I have a question to you. I do have a farmer here in Southeast Michigan that he grows popcorn called strawberry popcorn, the little one that you can see in the picture there. And what's happening is he has head mud. And I actually have other pictures here. Let me share that for you. And the problem is, looks like he's told me that 60% of his field got head mud. And the corn is only 25 days to get ready to harvest, he said. And what we know about head mud, that goes from the tassel, and he said that's in the tassel. There is no disease in the ear yet. So the question that I have, I'm trying to share here this one so you can.
I can say it.
I want to show you the pictures of the disease, and it looks like, so the whole thing is I'm wondering if he has 25 days to go until he can harvest, and there is nothing to do. So I'm wondering, do you think that in 25 days that disease is gonna get out to the ear, or he just should go and harvest later? So what do you think that's gonna happen? Because there is nothing we can do right now anymore. He might even had a nutrient deficiency in the past, but now it's just too late to do anything. So what's the recommendation at this point?
Yeah, I don't think it's going to move down to the ears. It looks like there's actually two different pathogens, one that affects the tassel and then one that affects the ear and some of the leaf material. So the one that affects the ear and some leaves and other spots on the plant, that's sort of a delicacy, right, in Mexico. But the one on the actual tassel there is a different species. And so I don't think that's necessarily going to move down to the ear, especially, if we're getting pretty far along here. It's not going to be at the right growth stage either, I'm sure, for infection and then development of these structures. It's going to need some of that younger material. If the ears are starting to really mature, then I don't think you'll get infection. So I don't really think there's going to be a concern. I'd certainly watch fields next year, make sure fertility is balanced. If it's on the there's sort of a little bit of conflicting data. I don't think we have much data in terms of fungicide applications for management. I mean, they're both fungal pathogens, so that fungicides may help, but the one on the tassel apparently has recommended that fungicide might help with that. The common smut we see, there's really no fungicide recommendations, which I thought was a little bit curious, but we just may not have the trials that we need.
All right, so the final message is pretty much we don't need to worry as much, and probably not going to affect the harvest whatsoever. Am I correct? I
don't think so. Right. Mm-hmm. The only thing I guess is when you go to harvest, those black structures or the structures on the tassels here are going to sort of explode and produce sort of black spores. So I don't know if that'll be. I don't think that'll be detectable. I think most of that will just blow out, but that'd be the only concern, I guess. You're going to make things a little bit dirty in terms of your final product.
Mm-hmm. All right. Thank you very much.
I think that's the answer Ricardo was hoping for, I think.
Right.
I have a question for Chris. Are you still on, Chris?
I am.
I've got some western bean cutworm traps set in dry bean fields, and I've got moth counts that are 3-4 times higher than I've ever seen them. They're last week 250 to over 500 moths in a week period. I know I don't have it in front of me, but I remember some guidelines from past years about cumulative moth traps, plus some evidence of pod feeding equals you better be spraying your dry beans.
Right. So we in the western U.S. they use a trap catch of like 700 or 800 as sort of a trigger. But Greg Varner back in the day had fields that were infested with as few as 120 moths caught. So we defaulted to kind of a lower level as the trigger, and then tell you to go out and don't spray when you're starting to see that pod feeding on the outside of the pod, which means they're probably small. They're probably third instars, maybe fourth. They're not drilling right into the pod itself. And once you see some pod feeding, in studies that we did with actually infesting, something like 12% of the pods fed on was 2% pick at the end, which is what they could reliably screen out with a gravity table or an electric eye. So when you start to see some pod feeding, that's sort of when I would time it. For the lower peninsula, this week would have been the week to spray. That would have been kind of the sweet spot. You'll kill what's there and you'll kill what's coming in another week or two. For you, it might be a little bit delayed, but I think that this would be a good time to spray. And those guys up there have had a history of infestation in those, is it white kidneys or cannellini beans, whatever was growing up there. And those
dark red kidneys mostly.
Whatever. There was some cannellinis up there as well. And those, that's a high moth catch. In fact, I don't have it in front of me, but if you look at all of the data and you compare Michigan to Ontario, they have many, many more traps than we do, but our per trap catch was higher than them this year. And we're past peak in the lower peninsula. I don't know where you are as far as peak. It was probably last week, correct? Or is it still?
I hope it was Monday. I don't want to see bigger. It takes too long to count them, and half of them are still alive because the kill strip gets buried.
Yeah. So, well, this is sort of for those of you who are trapping, instead of that kill strip, which I don't like to use, it is an organophosphate. You got to touch it. You got to somehow stick it in there and not forget to put it back in. I actually got some of that camping spray, gear spray that's permethrin. The stuff you can spray your pants or your tent or something with for mosquitoes. And I actually sprayed the inside of the trap. And a lot of insects will be repelled by permethrin, but these moths seem just stupid as anything. So the males fly in there. I'm not saying males are stupid, don't quote that, but there are males going in the trap, and once they get in there, they can't get out. And that permethrin does a really nice job. And I think it's a lot safer. And I think one treatment will work for the whole season, and it's easier to use. So that's my tip that I've come up with.
Chris, I think you got muted there when you made a comment about males.
I hope so, because I didn't. Male moths, I should say, cannot get out of the trap. So
well, little permethrin can't get in the way. Okay, thanks.
Welcome.
Let's see if we got anything new in the chat here. Okay, there was a couple things I think Marty has addressed.
Seeds from China. There's the thing from seeds from China. I did not get the seeds from China, and I'm sort of disappointed. I wanted to see what they were.
I've been seeing that in the media, but I
think you're supposed to send them into MDARD or USDA, and they're testing the samples, I guess, to see what they are and then what's on them.
APHIS, I think, was responsible for that.
Okay.
And with USDA, I saw a clip that said the preliminary response was it was a variety of things. It sounded vegetable. There was a number of things, but it was a mix. It wasn't all the same. That was the original. They didn't see anything really noxious, but it's pretty unusual, I guess, to say the least.
For those of you on the phone, we did have a question: how long can tar spot disease remain in corn residuals, especially in no-till corn on corn? And Dr. Chilvers responded, unfortunately, the tar spot fungus can survive at least 1 year on residue. The bigger issue is that the fungus is dispersed on the wind, and we've seen soy corn rotation fields and some that had never previously had corn get hit severely with tar spot. And then he provides an internet link for helping to identify tar spot.
I actually have a question for Marty on that identification. I was in a cornfield looking for tar spot yesterday, and I found a leaf, and it was actually a shiny black spot. I took the leaf, but it dropped, and I could not find it. So fortunately, I don't have it with me, Marty. But is it shiny, or is it a dull black color?
It's a dull black, yeah.
Okay.
So yeah, I put together a YouTube just to help people differentiate things. So this image I'm showing now is tar spot on the top leaf and insect frass in the bottom leaf. So the other thing I'm looking for is pretty subtle, but the tar spot lesion will typically follow the leaf vein, right? And then with tar spot, turn the leaf over and you'll see like a yellow lesion or that black lesion protruding through the other side. So I think that's one of the key things. Turn the leaf over. Is that lesion protruding through or not? If it's insect frass, it might not rub off very easily because it's dried to the leaf. Get a little bit of spit on there and rub it, and if it's insect frass, that'll end up dissolving. But tar spot will not dissolve. And tar spot's also got a little bit of a raised appearance to it. So that's a tar spot lesion here. So that's what we're looking for, right?
That could have been honeydew if it was shiny, and if you licked it, it would be sweet.
Thanks, Chris.
I'm just giving you tips here. So
is this the preferred scouting method from here on out, Chris, or what?
For aphid honeydew, yes.
Yeah. So I mean, we definitely had people confused previously, and I know fields had been sprayed as well. Freaking out about tar spot, and I think rightly so, especially after 2018. But yeah, definitely want to make sure we get a good confirmation on that. The other thing I look for is just a very slight yellow halo around that tar spot lesion. It can be kind of subtle, but yeah, something else to look for.
So Martin, I got a quick question for you. When we start to see this spore deposition over the top and we get direct infection on those upper leaves, is that when really things start to fall apart fast, or is it just like having it in the lower canopy?
I think it really depends on the pressure, right? I think we can have tar spot moving in onto the upper canopy, and yeah, I mean, as long as the infections are pretty light, it's not going to be a big deal. I think what happens is that if we're corn on corn in particular, you'll often see lesions start to develop on the lower canopy, right? Because it's getting splashed from that debris and initiating the infection down low. Later in the season, we very often see it on the tops of the plants, and it sort of indicates that it's being blown in either from this field or from a neighboring field or some distance away. But I think it's all about severity and how much longer we've got to go in the season, and how the weather plays out. And I don't know, Jeff, if you have any comments on dew period, and I mean, it always seems that we get a lot more dew in August, right? I don't know, what your comments around that might be.
You're right on. There is a climatology and a seasonality to it, and we know this from our, again, a long-term climate. Our highest dew point temperatures are now. The last couple of weeks of July into August, or through August, and then actually into the first week of September. And so that's when we have the most water vapor out there, and that is when we see typically the heaviest dew. This morning's a good example of that. Yesterday morning as well. It's just part of the climatology. So we're sort of in the peak of that time of the year when we expect to see that. It may be better termed, this is the most consistent time of the year. We tend to have a higher frequency, more regularly have dew at night than we do at other times, especially earlier in the growth. That can swing from one extreme to another pretty rapid. But typically once you get to August, it's fairly consistent each night. There tends to be some.
Thanks.
I'd like to go ahead.
I was just going to say, please go to the chat box and click on that link for the evaluation. And producers, we do need your help on this. It's very important for us to have the feedback so that we can make this program better and improve what we're doing each and every week as well as we go forward. So with that, I'll turn it back over to you, Jim.
Okay. I do want to urge you, please, to go to that evaluation and give us some feedback.